Hi, Year 12. You can see I'm going through the 2018 May TZ2 Paper 2. The first question here, I've already entered the data and done a statistics stat calculation on it of linear regression. And you can see I've got my values here. This is my value of the equivalent A, so that's M. B is B. And I know I said in the class briefly that you won't be given your correlation coefficient from your calculator, but you actually do. These are the two values. Your correlation coefficient is R. R squared is your coefficient of determination. And that's actually not done in your course for standard level IB. So you just be writing this one down, which is R. Correlation coefficient is your R. Part B is just straight substitution into your formula. Question 2 is straightforward. You're using your sine and cos rule respectively to solve for part A and part B. Question 3, the only trick would be to make sure you're in radians in your graph section of your calculator. You'd use your calculator to analyze your x-intercept, which you should get 1.14. And then to get the area enclosed, which is this part, the volume of it revolves around the x-axis, you would have pi times that region from 0 to 1.14 of the function squared, so sine e to the x all squared dx, and you use your calculator to analyze this. You don't do it by hand. It's only 3 marks, and it's calculator allowed, so make use of your calculator for that. Question 4 is also straightforward. When you get to the least value of n in part C, n solving Sn equals 163, whatever formula you use for this, which is, I'll just do it, 4 times 0.98 to the power of n, because r is 0.98, and you could have them the other way around. That's also another formula, same thing. You actually get n equals 83.523. But to actually get Sn greater than that, and n is an integer, it must be 84 then, rounded up. In question 5, we're looking at your binomial expansion. So from your formula booklet, you'll find that the binomial expansion is actually given from the whole thing is provided, if this loads. Here. So over here, the most useful part is this circled part in blue, where the rth term is NCR a to the n minus rb to the r. So back here, the rth term is of this form. So it means that if I want the term with x cubed, I'd first use what I've got. So n is 9, a is 2x, and b is k over x. I'm going to write x to the -1 because that's the same as k over x to the power of r, because that allows me to analyze my coefficients very easily. That means to get x cubed from here, I'd look at my coefficients, which would be 9 minus r when I combine them, plus -r, and I want that to equal to 3. Therefore, r should equal to -2r, so divide should be 3. And to get x to the 5, you'd have 9 minus r equals to 5, so r would end up being equal to 2. That means your terms end up as 9c3, 2 to the x, 9 to the power of 9 minus 3, which is 6, k to the x minus 1 to the power of 3. And you have here 9, 2, 2x7, k to the x, k times x to the -1 of 2. Now it says the coefficients of them are equal. So if I were to just take the numbers out and ignore my x's, it means that that coefficient equals to this coefficient. You'd use nsolve and you actually get k equals to 6 over 7. Your calculator gives it to 0.857, which is okay. Or you could analyze that and give 6 over 7. So it was all about understanding this part, taking this and turning it into that from your formula sheet. Question 6 was, I think this was straightforward. You just needed to interpret the question. There was nothing special about it. Make sure, again, you're in radians. Question 7 was actually a bit tricky. I'll show you why. On my calculator, I'm going to add a new page for a graph. Before I do that, to solve, I'll just do the whole question from start to finish. In part A, it says that the vertical asymptote is x equals 3. Find the value of c. So if the denominator can't equal to 0, then x must not be able to equal to negative 6 over c. That would be my asymptote. But since they said that the asymptote is x equals 3, I can equate this section and therefore c would be negative 2. So your actual function now is f of x is 8x on minus 5 over negative 2x plus 6. Right? In part B, it wants the horizontal asymptote, and you obtain that when x approaches infinity. So if you were to sub infinity in using some logic, the plus and minus 5 and the plus 6 don't actually make that much of a difference when I'm talking about infinity. However, if I multiply infinity by 8 and negative 2, it actually does make a difference. So if I look at this, the same big number divided by the same big number should cancel out, and you end up with negative 4. So your asymptote, your vertical asymptote, horizontal because x approaches infinity, and that would have the equation of y equals negative 4. There. Alternatively, in your calculator, you could just substitute in a massive number like 10 million, and you can see, you would actually see it approaches negative 4. In part C, this is where it's a little bit tricky. However, using your trusty calculator, it'll make sense. I want to type in my function in an absolute value. So, oops. But you can see already, using my absolute value sign, if I put 8x, x is bold because I actually had x saved in from the spreadsheet from question 1. So before you begin, you actually need to clear all your variables. Oops, didn't mean to do that. I just make a new page, file, edit. Menu, actions, clear A to Z. Then I go back to that page. I'll insert my function. Let's just delete all this. X. It's no longer bold, so it's forgotten that the x was entered from my first spreadsheet. And I'll have negative 2x plus 60. Okay, so you can already see by zoom fit that there's a point where, just making sure I typed in the right equation. Yep. In Sorry, I don't know what happened before, but I've just graphed it again into a new document, and you can see that we've got two asymptotes here, and we've got this nice part here. So the only points where you only have y equals k, which is a horizontal line, intersect your graph once would be at this point down here, which if you analyze it will be the minimum. Yep, and that occurs at y equals 0. And the other one would be where this line approaches the asymptote and this line approaches the asymptote. So the asymptote, you remember, was y equals to k, which is -4. So that means that when I took the absolute value, flipped everything, the -4, to become a +4. So that line should intercept y equals 4, whereas this one won't. That means your asymptotes are y equals k when it's 0 at the minimum point, or 4, just from sketching your graph. Question 8 was nothing special. Just thinking, I don't think there was anything in there that I needed to go through specifically. Question 9. Oh, question 8. It said hence or otherwise find the shortest distance from R to the line PQ. So from part B and C, you actually established that if I had P here and Q here, this would be vector PQ, and R was actually somewhere here. So to find the shortest distance from R to PQ, I'm going to establish point N, which is the perpendicular point from R. Rn is the perpendicular vector to PQ. So to get the shortest distance Rn, we actually already found the angle between PQ and PR. So PQ and PR here, we've actually got that angle already as 1.33 radians. So instead of using your distance formula and doing a dot product to get the perpendicular point or whatever, like a typical question, you can just actually use the right angle triangle, where sine 1.33r would equal to, so 1.33 radians is equal to Rn over, we've already got PR here, because it would just be the length of this, which is 36 plus 1 plus 9, which ends up being 46. And then you just solve for Rn, giving 6.59. So that was actually a really clever way around that question. I quite liked it. Question 9. No. There was nothing startling about this one either. Okay, question 10. I briefly went through it with a student who hung back at the end of last lesson. Let me just rub out a couple of things so it looks simpler. So it asks us to write down the value of k. You can easily get that just by thinking all these probabilities have to add to 1. And then to get the value of k, if you graphed it, you actually end up realizing that it is nicely symmetrical. Where if you've got mu here, got that, 93 and 119, they're symmetrical because they both have the same probabilities on the upper and lower end, which means the midpoint, which is 106, would have to be the mean. Then to answer the rest of the questions, you actually need to find the standard deviation, and you obtain that by putting it using inverse normal and your z-score. So the work solution is there. You can pause it to have a look.